This time we have two other functions, 1 over x plus 3 and x squared minus 4x. Determine an explicit equation, and then this time it says we just need to find the domain. So again, I'm going to give you time to do those on your own, since you already know how to do the explicit equation. F of x is 1 over x plus 3. And if you put 1 over x plus 3 into g of x, whatever you put in gets squared. And then you subtract 4 times whatever you put in. And so this is what it would look like unsimplified. In B, f of g of x, well, g of x is x squared minus 4x. And f says whatever you put in, you do 1 over that plus 3. So this would equal 1 over this plus 3. Now, for finding the domain, we just have to find the domain. Part of the reason we just have to find the domain in this one is this graph is not something that we graphed in transformations, and neither is that graph something we graphed in transformations. So they're just saying, can you look at this and can you tell the domain? Now, domain is looking at your x values and what's possible and what's not possible. And when you're thinking about what's possible and what's not possible, well, we know a couple of things we're not allowed to do. We're not allowed to divide by 0. We're not allowed to take square roots of negatives. So we've learned a couple of things that are not possible. When we look at this situation, there's no square roots, so the only thing that comes up is, are we ever going to divide by 0? Are there any x values that would be bad? And in this case, negative 3 would cause us to divide by 0. So that's all you have to do for domain. In this one, right, if I take the brackets away, I have x squared minus 4x plus 3. Would the bottom ever equal 0? What would help us find out if the bottom ever equaled 0? To factor this one. So if I factor this, x minus 3, x minus 1, the domain x can't equal 3 and x can't equal 1. Now, with dividing and checking for non-permissible values, you not only have to check your explicit equation at the end, you have to check all the way through everywhere that you're dividing. Now, in the first example, we're dividing by x plus 3 here. We're dividing by x plus 3 here. We divided by x plus 3 here. They're all the same. And so your non-permissible value is still just x can't equal negative 3. But our practice question that we're going to do for this one, and we're going to do it together, is 6D. So if you turn to 6D right now, f of x is 1 over x minus 1, and g of x is x squared plus 2x, but you don't need that because you just have to find f of x. What I want you to do is find that explicit equation and simplify it. Okay, check how you did. So f of x is 1 over x minus 1. And then f of 1 over x minus 1 is going to be 1 over, and where the x is, you plug in a 1 over x minus 1 minus 1. So this is the unsimplified version. We have fractions inside of fractions. And the place that we really improved our skills with fractions inside of fractions was in identities. So what do we do if you have fractions inside of fractions? Well, we want to get this to be a single fraction. So if we could get a single fraction in our numerator and a single fraction in our denominator, that's going to help us. Right now, I have a single fraction in my numerator. Do you see that that 1 can be 1 over 1? But on the bottom, I need to get this to be a single fraction. I'll need a common denominator here. So I'll multiply 1 by x minus 1 and x minus 1. That will give me 1 minus x minus 1 all over x minus 1. Because now I have a common denominator, so I can subtract those two fractions. Why didn't I have to multiply anything on the top? Because I'm trying to get a single fraction on the bottom and a single fraction on the top, so that at this point, when I have 1 over, and on the bottom I have x plus 2 over x minus 1, I can think of my top as 1 over 1, and my bottom as x plus 2 over x minus 1. Fraction divided by fraction. Multiply by the reciprocal. And so when we simplify this, we get x minus 1 over x plus 2. Yes? Oh yeah, 2 minus x, thank you. That minus sign. And 2 minus x. Excellent. So we've got a single fraction now. If you wanted to say, what is the domain of this function? And this is the reason I wanted to do this one together, besides giving you a chance to re-practice your fraction work. What's our domain? Do we have any non-permissible values? What can't x equal? If we look here, what would make us divide by 0? 2. So x can't equal 2. But the reason I wanted to do this example is this is an example where if you just look at your final answer, your only non-permissible value is x can't equal 2. Because you're dividing right here by 2 minus x. Are there any other places in all of our work where we're dividing? Yes. We're dividing here. We're dividing here. We're dividing here. We're dividing here. So when I look back at all of the places I was dividing, I find out I have another non-permissible value. We also know that x can't equal 1. It's okay that it can be 0 in the numerator, so this x minus 1 in the final answer at the top, that's not causing the problem. But the fact that earlier we were dividing by x minus 1, that means we have to include that in our non-permissible values as well.